Hello to all of you dear friends who are interested in Python programming language. Thank you for being with me in another educational video of this powerful language. The next discussion is specifying a regular expression for the shortest match. In the discussion of regular expressions, one of the problems that occurs is that you want to search for something and match something in a text. But what regular expressions return to you is the longest answer. It means the longest distance between the first quotation and the last one. This is more understandable in the example. How to find the shortest? Where does this problem occur? A commonly used example is where you have expressions inside double quotes and you want to find and return it as a search term. At first, let's import the RE module. Actually, let's restart the kernel. And again, let's import the RE module, and then we have a predefined pattern in the variable which is named a path, and we compile it with this pattern. Actually, in this pattern, we use backslash to identify the quotation. These backslashes are for identifying these quotations. We want everything except actually new line. The dot refers to everything except a new line, and you know that this star refers to the numbers, any numbers, 0 or more. Okay, and then we have this text which is an string, and we want to find this pattern in this text, and you can see that here the regular expression returns to us the longest answer, the distance between the first quotation and the last one. Actually, now we define another pattern in path2 variable, and we get help from this question mark. And this time, when we apply the final built-in method on this text, you can see that we got the desired result. Actually, you can read more about these tricks and concepts and the documentations of Python itself in this website here. Okay. Let's go to the next discussion, which is normalizing Unicode text to a standard representation. Suppose that you are working with Unicode strings and you want to be sure that they are displayed the same. Let me give a brief explanation about Unicode. Computers work with numbers. They only know 0 and 1. So, for example, we have to convert every alphabetical letter and symbol into a number so that it can be understood by the computer. It doesn't matter what language these alphabets are in. For example, they may be English, Chinese, Arabic, Iranian, actually Persian, Japanese, Spanish, German, or French, or any other language. All of these must be converted into numbers to make them understandable to the computer. It means that some kind of coding is needed. A conversion is required. Therefore, to unify and avoid chaos, a standard is provided. The name of this standard is Unicode. This standard has access to the alphabets of all living languages in the world and can convert them into a Unicode for computer use. So, for example, you can search for Persian character Unicode. Actually, the compart site also has good information in the discussion of actually Unicodes. You can search different letters in any language on the compart site. Here you can search. to find the corresponding Unicode. Okay, now in this Persian alphabet Unicodes, we want to write Ghazal, which is my name in Persian. I wrote it as a command with Persian alphabetic letters here, and I also defined a Ghazal variable, and you can see that here we can find the letters here. For example, we need this one, which its Unicode is U063A. We wrote it here. Pay attention to these backslashes. We need these backslashes in this kind of conversion. All of the Unicodes starts with U, and when you search them in somewhere like, for example, Wikipedia's and Compart sites, these are these plus signs, but you do not consider them when you are working with environments like Jupyter Lab and Jupyter Notebooks. So write this U and write the other part, the right side of actually this plus sign, but pay attention to the fact that in the Unicodes which has letters, actually all of them has one, which is U. Some of them, in some of the Unicodes, the other part of the Unicode is just numbers, and in some cases the other part also contains letters. Pay attention to the fact that all of these letters should be in small form. Okay, so we wrote the U063A, and actually we need this character. Here we search for this character, and we find its Unicode U0632. We wrote it here with another backslash, and the last one, which is this character, we find it here, and its Unicode is U0644. We wrote it here with another backslash. When we show this Ghazal variable, you can see that the result, the output is similar to what we wanted. Okay. In some cases, you can make some of these characters with a sequence of these Unicodes. Actually, I recommend you to try some similar examples in your own mother language. Okay, here I defined S1 variable, which is I wanted to reach the El Nino. In order to reach to this N tilde, here in S1 I used the N tilde actually Unicode, which is available here in the Compart site. You can see that the Unicode is U00F1. I wrote it here, and the O at the last part, and you can see that when I show this S1, the output is desired. Actually, I defined another variable, actually string variable as S2, and this time I separated this N from this tilde sign, actually the tilde character. And I wrote the N and then considered the backslash and the Unicode form of this tilde, which is a 0303, and the O at the final stage. And you can see that when we write them, when we actually run them, the S2 represents the same output. Now we want to have a comparison between S1 and S2, the output is false. Why? Let's check their lengths, and you can see that their lengths are not equal, so this comparison result was false. The length of S2 is 1 more unit because in S2 n and tilde, two characters are separated from each other. In analyzing such texts, you need to use a normalization mechanism. What is presented is a normalization method. This means that when you have two threads whose display is the same, you also match what is behind the scenes. Python itself provides us with this normalization. In order to achieve it, we need to import the Unicode data. You can search Unicode data Python and enter the Python site itself and read about this here. Okay. This Unicode data has a method called normalize. This method has several forms. If we use NFD, that means we have to isolate. For example, we must separate n from tilde. If we use NFC, it first separates the components and then combines them again. These forms follow canonical equivalence. Another mode for this equality is compatibility. For example, the Roman numeral 1 is similar to the English letter I. For example, compatibility equality can be used for this. You can read more details on the Python website. Let's come back to our Jupyter Lab and define another variable S1n, which is a normalization form of this S1 with the form in the form of NFC, and also define the S2n variable, which is the normalization of this S2 string with the similar form NFC. Now let's represent this S1n and also represents this S2n. You can see that their representations are similar still. Actually, they are similar, but this time if we comprise them with each other, you can see that they became actually equal. And okay, so in cases where you work with Unicode, despite the appearance being the same, if there is no equality behind the scenes, you have to do normalization to do different processing on them. Actually, let's show the ASCII code of them. You can see that now the ASCII codes of them are similar too. So you can see that they became the same after normalization. Now what is ASCII? You can read about it on Wikipedia. The ASCII code is also a standard type and is related to Latin letters. Now there are a series of operators and famous characters such as new line that must be understood by the computer. You can see that each of these characters has a corresponding binary code that can be understood by the computer. These codes are not specific to computers. Devices such as printers also use them. These normalizations are needed to transfer actually information and do anything without errors. If you want to find the ASCII code of anything, you should use the ORD function. Here, for example, I applied the ORD function on the small form of a letter N and also the capital form of them. You can check the outputs with Wikipedia. The opposite of the ORD function is the CHR function. And now if you apply the CHR function on the output of this, applying this ORT function on the small n, you can see that you have the output small m as output of this CHR function. And also this is the same for 77, which corresponds to the capital form of m. Actually, you can do the same for the letter E, and CHR of 69 will be the same. Okay. When you use the expressions that are not in the ASCII table, we use the escape character. This character provides a different interpretation for its next characters. We have something like this with the backslash in regular expressions. You can see that this character has the same role in the ASCII code discussion. Okay, let's define another, for example, S1 and 2, which is the Unicode data that normalize. And this time we want to do this normalization in the form of NFT on the same S1, and also we want to do the same okay, let's show them. I have an representation of each of them. Now let's check if they are equal in this way, and also we want to show their ASCII format. Actually, we want to do the same for S2 and 2. Okay. You can see that the output has changed, and this is totally logical because the form of normalization has changed. Do a comparison between the last outputs and these outputs. You can see that there is a change. There is a difference actually. Now let's use Unicode data that normalize with the form, for example. Let's define another string. S is equal to, for example, a backslash UFB01, and let's show this as simultaneously. This is the F and I characteristics sticking together. Now let's use the normalization. You can see that it cannot work because it is not a suitable mode for NFT. Okay, of course, let's change them now. Let's try with another forms. For example, NFC Okay, let's see what are the others. Anafkasi and Anafkadi. Let's try it with Anafkadi. Okay, when you use it in the form of anafkadi, you can see that it cannot work because it is not a suitable mode for anafkadi. Okay, let's check it with anafkasi. Okay. Okay, actually, we wanted to do a separation here, but the NFD and NFC are not suitable for this purpose here. So we need to do it with the form NFKD and NFKC, and you can see that it is desired separation. Is achieved here. So depending on the field you have and actually excuse me, the string you have, choose the normalization method. This normalization is very useful in the real world of Python. Do not think about this complicated discussion. You learned two things here. The first one was Unicode, to use the living languages of the world and their coding in order to be comprehensible to the computer. A standard method has been introduced so that we do not encounter errors and problems when sharing. Now we said that this is the source of the problem because, for example, you have the Unicode of n and you also have the Unicode of tilde and tilde. But in fact, these may be made in different ways and have the same appearance. To solve this problem, normalization methods have been introduced. The ASCII function returns a readable version of any object, and you can use the escape character for anything that doesn't have an ASCII code ready. Let's see, print the ASCII form of, for example, this. Let me check if we can do something like this. The ASCII form is similar. Now let's see the ASCII form of these. Okay, these are actually can we do the same with these? For example, if we want to show the ASCII form of these. Okay, we did it actually. We have shown the ASCII format of this El Nino, which is the output of S2 and 2. Actually, we see it here, but I want to check if we can do the same here. Okay, you can see that you can achieve it by putting the string itself as the input actually of ASCII function. Okay, thank you for being with me in another educational video of this widely used programming language. I still suggest that you stay tuned because they are very practical and secret tips in the next videos that I will reveal to you. Have a nice day.